find the winner of the circular game. So we are given n number of friends, and they are in a circular fashion, sitting in a circular fashion, and we are given an integer k also, and at each step the k person has to be removed from the circle, right? At each step the kth person will be removed from the circle, and whoever is left in the game will win, right? We can see the example. Let's say we have n equals to 5, so there are n 5 people, and k is 2. So in a circle we have 5 people: 1, 2, 3, 4, 5. So the game will start from the first person here, right? So the k is 2, so the second person has to be removed. So who is the second person? Second person is 2. So he will be removed. So we are left with 1, 3, 4, and 5. Since we have removed 2, will stand at 3. This will become our starting position. And again we have to remove the second person from the starting place, so it's 4 this time. So then 4 will be removed, and we're left with 1, 3, and 5. Now this time 5 will be our starting place, and again the second person. So this is how it started. Now we have to remove 1. 1 will be removed. We'll be left with 5 and 3. Alright. And again now the starting place will be 3rd. So this 5 will remove 5, and we are left with 3. So 3 is our winner. That is straightforward. But the question is how we are going to implement it. Okay. So first thing we have to identify that we have to store these values somewhere, right? And then we can start removing it in each iteration, and whatever value we are left with, we'll use it. So we'll first see the list approach, if we take an array list, and how we can do it. So take a list and store all the values like 1, 2, 3, 4, and 5. So we'll just use a for loop to I to n, and we'll store everything in the list. Okay. So once we have everything in the list, we need to keep a variable to store the starting place from where we are starting. So when we are starting the game, actually we are starting at the 0th place, right? So starting place would be 0 in the beginning. And how long we are going to do this iteration, removing the players from the game, until we are left with only one person. So our condition, what should be our condition? When list size, if it's greater than 1, then we'll keep on iterating, right? So we'll just add it to the while loop. This will be our condition. If we have more than one player, then we have to keep on iterating it. Now we have started the game. We have the value of k. So kth place needs to be removed, right? So if we see it very clearly, when the value of k was 2, we have actually moved only one place, right? Let's say if the value of k will be 3, we'll start from 1, 2, 3, 4, and 5. So starting place is 1. So third one, we have to remove k equals to the third one. So we have to remove 1 and 2. So we'll remove the third place, right? So if k is 3, we actually move 2 steps, right? So we actually have to move starting point plus k minus 2 steps, right? This is the starting place. So we are moving actually k minus 1 steps. So if we see int player to be removed, which player we are going to remove? It will be starting place plus k minus 1. But then we have to think of one more thing. Suppose we are starting from 1, 2, 3, 4, 5. And let's say k is 8. So if we recall any rotation questions problem, if the k exceeds the number of the size of the array, we don't bother it, because if we start iterating on the circular loop, what we have, like 1 place, 2 place, 3 place, 4 place, 5 place. So after each 5 place, we'll be back at the same place. So we are not concerned with the extra 5. Like, why to rotate on the loops for so many times? If it's like 80, right, it doesn't make any sense, because we keep on iterating, and ultimately we are only concerned with the last remaining steps. Let's say it's 12. So 1 step, 2 step, 3 step, 4 step, 5 step. With each 5 steps, we'll reach again the starting point, right? So it's like 5 plus 5 plus 2. So this is like we reach again the starting point. We again reach the starting point. So we are only concerned with the last 2, right? So it's better to do the modulo, because we are only concerned with the remaining portion. So why not to just do if we have k equals to, let's say, how much? 12, or k equals to 8. Actually, we only have to rotate in this scenario. Size is 5, so we have to only rotate by 2. And if in this size is 5, then we will rotate by 3. So we have to like do the modulo by k in order to get the only the desired one. Because what could happen, right, if the starting place is this one 0 and we do 8, so it will become 8 minus 1 we do, because we minus 1 step. So 7 will get out of bound, right? So in order to adjust it so that it doesn't get out of bound, 0, 1, 2, 3, 4, 5. So if the value is within these limits, then it's perfectly fine. As if it starts to exceed, then we do the modulo, and it actually reassigns it to the back of the array list, right? So the next player to be removed would be starting place, from where we are starting, to then we'll add k plus 1 steps, and we'll do modulo by list dot size. This will give us the which player we need to remove. Then we can simply use the remove function, list dot remove, and this in index what we got removed. And then see, once we are removing somebody, like in this scenario, once we remove 2, it's actually 0 index, it's index 1. So once we removed index 1, 3 become our new starting point, right? And it is nothing but the index that was removed. So the starting place will become players to be removed. And this should be done, right? And we have to return whatever element we are left in the list. We'll just return it, and it should be fine. Now let's go to the coding. Alright, so first we have to take a list where we'll store all the players. Okay, players, new array list. So once we have taken the player, we have to populate all the players. So it will be from first to n, and we'll just add players dot add. So now we have added all the players. So initially we'll start with the 0 place, right? So int initial and starting index is 0, and we have to continue this iteration on till when we are left with only one person. So if there are more than one person, we'll iterate on the players list, right? So now we need to know which index has to be removed. So int index remove, or we can say player to be removed. So once we are starting from this place, it has to move k minus 1 steps, and just to make sure it doesn't go out of bound, we'll do the modulo. So starting index plus k minus 1 modulo players dot size. Perfect. So this will be removed. Remove. This player was removed. And now we have to update our starting place, starting index. So now we'll start with this index itself. Right. And once we are done, we'll only have one element in the list. And we can just return it. Let's try to run it. Submit it. Man, it's done. Now let's try to see the another approach using queue. Alright, so we'll add everything to the queue. Okay. We'll add everything to the queue because we are going to solve this question using queue. So we'll add it. We'll add 1, 2, 3, 4, and 5. So 1, 4, 3, 2, and 1, right? So once everything is added, again, we are going to follow the same logic. If the size of the queue, I mean, there are more than one elements in the queue, means you have to remove it. So let's try to visualize how it's going to look like, right? How does it actually happens? So we start with that first place, right? We start with the first place. Then we get to the k minus 1 step, and then remove it, right? So if we go to the k minus 1 step, that is like is in our scenarios 2. So we'll move one step. We came at 2. If we try to remove this one, right, since it's a circular one, we'll start from the 3. So 3 to 5, but then it should have 1 here, right? I mean, it's a circular one. So if we start with 3 to 4, 5, and then we have 1. So how can we move 1 from here to here, right? It's because it's a queue. It's very simple. All we have to do, we'll pop it out, and then we'll add it to the queue. Right? We'll pop it out and we'll add it to the queue. Let's say if in our case, if the k was something different, like 6, 5, 4, 3, 2, 1, we had n equals to 6 and k is equals to, let's say, 4. So how it's going to be look like? We'll start from the first place. And k is 4, so we have to move 3 steps. 1, 2, 3. So this has to be removed. But all these needs to be at the left side, right? So it's very simple, right? We'll, instead of directly reaching out to that place, we'll first iterate on the queue. We'll pop everything. Like we have to go till the third step. So till the second step, we'll pop everything out. We'll pop it and we'll push it. We'll pop it. We'll push it. We'll pop it and we'll push it. Right. So we'll have 1, 2, 3 here. Perfect. And if you try to see it via diagram, 1, 2, 3, 4, 5, 6. The moment we remove 4, what do we have? Why we have 5, 6, 1, 2, 3. So we are like 5, 6, 1, 2, 3. Right. So whenever we are, now this becomes our starting point, right? And then we'll start from here itself. Again, it will go to the kth place. So before going, these will be moved to the frontal side, right? Let's say the code, and that will help us to understand even better. I'll just try to write a pseudo code here. So first, what we had to do, since n is given, let's say 5, we'll use a loop I to n, and we'll take a queue, and we'll add it to queue. Right, we'll add all the element. So all the players have been added. Now we'll iterate on it unless we are only left with one element. So if it has only more than one element, the size is greater than 1, we'll keep on iterating it. Now we have to use a for loop. Again, how many times it will run? See, if the k was 4, right? So 3 elements. The 3 elements needs to be popped out and pushed in, right? So it will I from 0 to how many times? K minus 1 times. And what we'll do? We'll do q dot poll and q dot insert. Whichever element we got, like we got x, we'll just insert it. So we have removed everything and now we are standing at here, right? This the q first element will be 4. So we just have to remove it now. So q dot poll. That's all. And this will take care of it. And we'll just return the last element. Q dot poll. And it's done. Now let's move to the coding and we'll see. Okay, let's start. Take a queue where we are going to store everything, all the players. So we'll take a queue. We'll add everyone to the queue. So it will iterate from I to N and we'll add everybody. Now we have added, so we'll have to iterate on it until it has more than one element. Now we have to move the first k minus 1 elements to the, we'll pop it out and move to the end, right? So we'll take a loop. It will iterate till k minus 1 and q dot add q dot poll. Perfect. Now just we have to remove the last one because now we are standing at there and it will be done. Let's try. And it's done, right? So what we did, like we are actually on the first k minus 1 elements, we are removing him and we are adding it again. So it actually moves to the left side and then this needs to be removed because he'll be eliminated from the game. And it will keep on going till we are left with only one element and then we'll remove that element and it's done. Now let's see finally the most optimal approach. It uses actually Joseph's formula. We'll say it. Now let's try to see how can we solve it using recursion. So for that, we'll take a bigger example. Let's say n equals to k6 and k is equals to 3. Okay, so we have 1, 2, 3, 4, 5, and 6. So we all know, right, if we want to solve anything in using recursion, we have to have an index because it's each state the value will change. All right. So we are starting at this place, right? We are starting at first place. So that will become its index 0. It will start from here itself. So 0 index 1, 2, 3, 4, and 5. So k is 3. So we have to replace the third player, right? So it's second player and third player. So the 3 will be removed from the game. All right. So what we are left with? We are left with 1, 2, 4, 5, and 6. Right? And what will become our starting place? 4 will become our starting place. All right. So if we try to index it now, 1, 0, 0, 2, 3. This is our new index. And if we further go, so k equals to 3, so 6 will be removed. This will be removed. So we are left with 1, 2, 4, and 5. And since we removed 6, so 1 will become our starting place. So this will become index 0, index 1, index 2, and index 3. Perfect. Now again, k equals to 3, so third place will be removed. So 2 and 3, so 4 will be removed. We'll remove 4. So we are left with 1, 2, and 5. Since we removed 4, 5 will become our starting, index 0, index 1, and index 2. Perfect. So 5 is starting, and we have to remove the third one. So 2 will be removed. So we are left with 5 and 1. Since we removed 5, or since we removed 2, again 5 will become our starting index. Correct? So again it will 0, and it's 1. And since we removed 2, this is again a starting index. And finally 1 and 2 steps. So we'll remove 5 itself. We are left with 1. And index will become 0. Right? This was removed. So which every time we remove it, our index changes, right? So index is changing, but k is constant. And also the number of players in the game is also changing. These two things are changing. And this is our end point, right? This is where we return the result when we have left with only one element. So if you wish to donate in a different fashion, what we can say? This is nothing but f of 6, 3. We have 6 elements and k is 3. This is nothing but f of 5, 3. 5 elements. We have 5 elements. And this is nothing but f of 4, 3 elements. We have 4 elements. And this is function of 3, 3. And this is function of 2, 3. And finally, f of 1, 3. So whenever n is equals to 1, we stop. And what do we return? We return the index as 0. Right? Because we have to return the index from the array, right? We have to return the index. So it's 0 because there is only one element, and obviously it has to be 0, and this is going to be our answer. Right? So if we try to, this we know, and we have to reach from f1 to fn, right? So every time we go from one state to another state, what exactly is the change? We try to observe it very carefully. We can easily see that for this is our answer. My answer is at 1, right? How its index is changing. Its index became 1, or let's better take from any place in between. Like my answer is 1, and it's at index 0. But if you go upside, right, its index becomes 1. So how the index is changing? If we see it's plus 3 only, like 0 become 3, so it's plus 3, like we are adding 3. If you see any other index like 5, the index of 5 plus 3, what it should be? It should equals to 6. But the elements are of size 5, right? So it will go out of bounds. So what we have to do, we have to adjust the index numbering. So what we'll do, we'll modulo with the size. So it's actually 5. So 6 modulo 5 is 1. So our index is 1. Correct only. 4 is at index 2. So if we plus 3, what we'll get? We'll get 5. And modulo 5 equals to 0. So it's at 0 only. If we try to see 2 is at index 1. If we plus 3, so it becomes 4. So you see it's at 4. Similarly, if we try to see here itself, right? This is at 1, right? If we try to add 3 to it, what do we get? We get 4. Since the element is here 3, right? So we'll do modulo 3. We get what? We get 1. So the index will become still 1, right? If we try to see the 5, it will become 3. 0 plus 3, 3, and modulo 3 is 0 only. So index is 5. So with every time we move up to the recursion, we have to add plus k and modulo of n to get the value. If we try to draw the recursion tree, like we starts from 6, 3, we go to 5, 3, then we go to 4, 3, then we go to 3, 3, then we go to 2, 3, Then we go to 1, 3. Well, this is our base case, right? This function, what will return? It will return 0, right? What it actually returns, it returns 0. So this was called by this function, right? And what it will return whatever it got from this function, plus we'll add k elements, and then we'll do modulo of the size, right? So it returned 0, this function, plus k. So k is in our case is 3, modulo 3. So what it will return? It will return 0, right? It actually returns what? 0 plus 3. Oh, sorry. 0, okay. Sorry, extremely sorry. It has to be, 0 plus 3 because it's k, modulo n, and n is 2, right? So it will return 1. So this function is actually returning 1. This returned actually 0. So since it has returned 1, we'll add k. So it's 3. We got 4, and then modulo, this is 3. What do we get? We get 1. So this function will return 1. And if we try to see, right, our index was 1, right? Now this has returned 1. So 1 plus 3, we get 4. N is 4, modulo 4. We get 0. So index will become 0, right? Index becomes 0. So what it returns? It returns 0 actually. So 0 plus 3, because it's k, so 3. Modulo 5, it's again 3, right? So this will return 3. And finally, we got 3 plus 3 is nothing but 6. Modulo 6 equals to 0. Perfect. So it actually returned the index. See, 1 is at 0 index. But since it's a 1 based indexing, we'll have to add 1 to it, and then our final answer, whatever we'll get from this is 1. So we'll just add plus 1 to it, and we'll get our result, right? So if we try to write the pseudo code, how it's going to be look like? This is our main function. We'll pass n and k, right? And whatever value we'll get from it, we'll just add 1 to it, because it's a 0 based indexing and we have to adjust for 1 based indexing, right? And if we try to define our function n comma k, what it will have? It will have a base case when n is equals to 1. If n equals to 1, return 0, right? Else what it will return? It will return whatever value it will get from the previous one, and minus 1k, and then we'll add k to it. And finally, what we'll do to adjust the indexing, we'll model it with by n. Perfect. Let's move to the coding. Alright, so just we have to create a helper function. Helper function, it will pass n and k, and whatever value you get from it, because we have to adjust for 1 based indexing, we'll add 1 to it, and then we'll create the helper function. It will return int help int n int k. Perfect. So base case, what was our base case? When n equals to 1, we return 0 because we are only left with 1 element. Else what will it return? It will return the previous function, and minus 1 it will call with k. Whatever value we'll get from this function, right, we'll add k to it. We'll add k to it, modulo by the n, right? And it should be done. Let's try to run it. Submit it, and it's done. So the time complexity would be big of n, and the stack space, because we are using recursion call, it will also be big of n. But if you try to see the question, right, it says it can be solved in a constant time, I think. A constant space. So what we have to do? So it's a recursion. We can convert it to tabulation. So it will be pretty simple, like, and by default what we'll take, this is our base case. Let's say winner is 0, and there should be more than one element, so we will start with 2, I less than equals to n, I plus plus. Okay, so how we convert it, right? I mean, if we go from the 0 to the next one, so winner is how winner is updating. Winner was updating like winner plus what we were doing, k steps, and the I is nothing but n, right? The change, when the change was it was changing to each steps. So if we do I, and what will return? Will return winner, and we have to adjust the indexing, so +1, right? I think it should be fine. Perfect. So now it's only in big O of n with constant space, right? That's how we can do it.